Welcome to class today, Geometry Scholars. Today is Thursday the 5th. Hope you guys are doing well. Hope you're ready to learn some math today, or at least review a little math. Now, let me be very clear about something. The only reason I'm going to go over this test with you today and then give you another test on Friday is because I received a couple emails, and when I say there were some complaints, everyone's attitude was great, and I appreciate that. But there were some complaints that some of you did not watch the video before the test. And I want to say the video was important to watch. Like any teacher who gives a test, I go over the test. And I'm not blaming Mr. Harmon. I'm not blaming myself. I don't know. Maybe I didn't communicate well. Maybe he didn't read it well. Who knows? And really, to be honest with you, who cares? I mean, I'm not into the blaming game. I'm into the fixing game. So let's fix this and let's see what we can do. Now, first of all, the video is important because what I did is I said stuff like this. And of course, you should have your test on your desk right now. If you don't, pause the video and respectfully raise your hand and ask Mr. Harmon for your test. Your test should be on your desk. Like, for example, I explained when I gave the video, I explained exactly what I wanted you to do on numbers 1, 2, and 3, because the directions could have been a little confusing. On these numbers here, I explained exactly what I wanted you to do, because the directions here could have been a little confusing. On number 13, I actually gave you the answer. If you listened to the video, you saw that I gave you the answer, okay, to 13, because my reasoning was, hey, if you don't know how to do 13, you're probably going to miss the rest of them anyways. But if I can give you the answer to 13, thus making the directions a little clearer, that's fine with me. And then I explained to you guys that these lines here were called mid-segments, and that's basically it. So the video was very important, and so because you missed that, I'm going to let you retake this test tomorrow. Now, letting you see the test in front of you and also allowing you to take it home, you can put it on a frame, hang it on your wall, throw darts at it, burn it, eat it, rip it up, whatever you want to do. That's up to you. But I will not give you this exact same test, you understand that, but it will be very, very similar. It might even look like the same test, but I'll be changing numbers and figures and stuff like that. So tomorrow we're going to retake this test, okay? Now, I'm sorry that you did not get to hear the videos, okay? And or the video for this test. And let's make a rule right now, and from now on I'm going to hold your feet to the fire, okay? And here's the rule. For the rest of the year, I will never give a test without a video you need to watch first. So if Mr. Harmon or whoever the supervising teacher is passes out a test and tells you to get started, you need to raise your hand and respectfully say, well, hold on, Mr. Harmon or whoever the teacher is, Mr. Earhart said there would be a video to watch first with this test. And then you guys can look it up there online or whatever you want to do. And so from now on, the rest of the year, I will now let me back up. When I say there will not be a video to watch, I mean, you understand the fill in the blank test, there's no video for that. Remember the fill in the blank test you took on Tuesday? I mean, there's nothing to say. I mean, you pass it out and you fill in the blanks. So I don't mean that test, okay? Is that clear? Part 1 tests that are fill in the blank tests, there's no video for those. You fill in the blanks, turn them back into the teacher, and then go ahead and watch the video for the review sheet, okay? But these types of tests here, the part 2 test where it's the actual math, there will always be a video to watch first before you take this test. So if that ever happens again and you guys don't tell the teacher, hey, we need to watch a video, what is the video? That is your fault, and I will not give you a second chance. So I want to be clear. I love you all. I care about you. And by the way, if you think I'm being too tough, let me tell you what I used to do for my classes at Tennessee Temple that were a track 1 class, okay? Their semester exam at the end of the year, do you know what their semester exam was at the end of the semester, and their year end exam at the end of the year? All 100% fill in the blanks. There was not one math problem. They had to have, I'm not kidding, I kid you not, I'm not exaggerating. They had to know definitions, postulates, corollaries, and theorems from day 1 in August all the way to the very last day, day 180 in May. It was back and front, 6 pages long. I kid you not. That was a track 1 advanced, or not advanced, but a a regular geometry class that would be like at Berean. They're a track 1 class. So just so you know, I mean, some of you might think I'm being too easy, some of you might think I'm being too hard. I do not do that to you guys, and I don't plan on doing that for your semester exam. But I'm trying, and by the way, breaking the test up into 2 days is another way that I've tried to be reasonable and helpful to you guys, and to give you and make it a little easier, yet still make you learn the material. Now, I did not look at your fill in the blanks yet. I was going to tonight, but then when I realized you were going to retake this, but you know, again, I love you all. I've told you that many times, but if you didn't do well in the fill in the blank part, there's nothing I can do. I guess I could start making you write them 5 times every day. Maybe that would do it, but really it's your job to go home and learn those and memorize those. Okay, so I'm not saying anything that I wouldn't say if I was there. You've got to learn to fill in the blanks. But from now on, the rest of the year, on your, not on your fill in the blank test, not those, but on your math tests like these, there will always be a video to watch, always. And if you don't remind the teacher of that, that's your fault, okay? So get out your tests. We're going to go over these tests, and you're going to take another test tomorrow, and hopefully we'll do okay. All right, here we go. You are to take notes on this test on a separate sheet of paper or on the test itself. I want you to really, really, really pay attention, okay? On numbers 1, 2, and 3, I want you to decide if the figure is a polygon. If you say yes, tell me what kind. You would say triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, etc. If it isn't, then tell me why it's not a polygon. Pretty simple. So number 1, is this a polygon? And you would say, no, it is not, because it has a curved side. Remember, a polygon is made up of segments. Boom, 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 boom. Segments. No curved sides. So no, this is not a polygon because it has a curved side. By the way, if I had this right here cutting through the middle of this, then I would not have a polygon. Because also the definition of a polygon is all of the sides intersect only one other side. And if you'll look at this drawing right here, this side right here, let me use my red marker. This side right here is intersecting this side, but it's also intersecting this side. And one of the definitions of a polygon is that each side intersects only one other side at its endpoints. Okay, so moving on. Number 2. Yes, this is a polygon, certainly, definitely. Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. So yes, it's a polygon, and an 8-sided polygon is called an octagon, like an octopus with 8 legs. Octagon. Okay. Is this a polygon right here? Yes, it is. Definitely. Made up of all segments connecting at their endpoints. Looks great. How many sides does it have? 6. So you would say yes. And what type of polygon is it? Hexagon. Hexagon. There's an A right there. Hexagon. Do you want to know the names in order? A triangle is a 3-sided. A quadrilateral, I'm going to abbreviate a quadrilateral as a 4-sided. A pentagon is a 5-sided figure. A hexagon is a 6-sided figure. A 7-sided figure would be called a heptagon. And then an 8-sided figure would be called an octagon. Okay, so there we go. That's how you're going to work out numbers 1, 2, and 3 on the test when we take it again tomorrow. Okay, all right, moving on. Hold on one second. I'm looking something up here real quick. All right, here we go. Numbers 4 and 5. For numbers 4 and 5, find the value of x. Now, what you should know by now, students, is if you have a triangle, the 3 angles on the inside add up to 180. Okay? If you have a quadrilateral, that's a 4-sided figure, the 4 angles add up to 360 degrees. Now, notice I have 4 sides here. It's a quadrilateral. And notice I have 4 sides over here. It's a quadrilateral. So, I know if I have a quadrilateral that all 4 of these angles add up to 360. So, here's what I'm going to do. I'm just going to simply say I've got, I'm going to have to write really small here, 110 plus 58 plus 64 plus 2x. I added all 4 angles together, and what do they have to equal? 360. Don't I have a nice equation right there? Sure I do. Now, I have 3 like terms. 1, 2, 3. Let's go ahead and combine those 3 like terms, and if I do that correctly, I will get, let's see, 0, 8, 2, carrier 1, 7, 12, 13, 3, carrier 1, 232 plus 2x equals 360. All right? Now, let's continue to solve the equation. This is a positive 232. Bring it over to the other side, and when you bring the 232 over, it's gone, and it becomes a negative 232. You change the signs. So you're left with 2x equals 128. 128. And then divide both sides by 2, and x equals 64. X equals 64. There we go. Students, it's just that simple. Please don't forget that when you have a quadrilateral, all 4 angles added together will equal 360. By the way, if I go too fast in this video, like I'm going to erase stuff now, just back up the video and watch it again, okay? It's no big deal. Didn't want that to happen. There we go. And let's continue on. All right, number 5. Let's add up all 4 angles, and we'll set them equal to 360. So here we go. We have x plus 78 plus 78 equals 360, right? So here we go. X plus x, they're like terms, 2x. 78 plus 78, 156. And there, I simplified my left side. I combined my x's and I combined my constant terms. Now, bring the 156 over and make it a negative 156. So we bring it over and it becomes a negative 156. So we're left over with 2x equals, and let's see, that would be a 0, a 4, 204. 204. Divide both sides by 2 and we get 102. X equals 102. There we go. I mean, really, it's that easy, okay? Let me grab a drink of water here. Moving on to number 6. The given figure is a parallelogram. Find the missing 3 angles. Find the missing 3 angles. All right, here we go. Oh, and by the way, well, let me get to that a little bit later. Okay, number 6, here we go. The given figure is a parallelogram. Find the missing 3 angles. Now, you should have learned this. We've been over this and over this. When you have a parallelogram, opposite angles are congruent. So if angle A is 142, then angle C is also 142. So I come over here and put 142. Remember, there are 5 characteristics we learned about a parallelogram. One of them is opposite angles are congruent. Another truth that you learn about parallelograms is that consecutive angles, or angles that are side by side, are supplementary. They add up to 180. So if I take this angle here, which is right beside this angle right here, and I add those 2 angles together, I should get 180. So if this is 142, I'm going to take 180 and I'm going to subtract out 142, and I'm going to get 38 degrees. So I know this angle right here has to be 38 degrees. Angle D, 38. How do I know that? Because if I add 38 plus 142, I'll get 180. Now also don't forget, just like these 2 angles that were opposite each other were congruent, well, these 2 angles here are congruent. They're opposite each other. So if angle D is 38 degrees, then angle B, as in boy, also has to be 38 degrees. So there we go. That one's not too difficult. All right, number 7, 8, 9, 10, and 11. Tell whether the quadrilateral is a parallelogram. Explain your reasoning. Now, I gave you 5 ways, and either you memorized them or you didn't, guys. That's just part of being high school students. Part of being, whether it's in a track 1 or a track 2 math class, there are still fundamentals. I mean, you had chemistry last year. Everybody had to take chemistry, and I'm sure there was a lot of memorization in there with that class, I would think. Knowing Miss Calvert, a good, solid, tough teacher, I'm sure there's memorization of definitions, terms, formulas, all kinds of stuff. You had to memorize 5 ways to prove that a quadrilateral is a parallelogram. The first thing, or one of them, was both opposite angles are congruent, both sets. Number 2, both sets of opposite sides congruent. Number 3, both sets of opposite sides parallel. Number 4, an angle is supplementary to both of its consecutive angles. Both is a key word there. And then number 5, if the diagonals bisect each other. Now, you had to memorize those, guys. I mean, there's just no other way to do this. You have to memorize it, okay? So the only way you can tell me that number 7 is a parallelogram, or number 8, or number 9, or number 10, the only way you can tell me that is if you have one of these reasons right here. So let's look at number 7. Tell whether the quadrilateral is a parallelogram. Tell me why. Explain your reasoning. Yes, it's a parallelogram. How do I know? Please look at reason number 3. Reason number 3. Both sets of opposite sides are parallel. When you have a quadrilateral in which both sets of opposite sides are parallel, then you have a parallelogram. Well, see this arrow here and this arrow here, that means those 2 sides are parallel. See 2 arrows here and 2 arrows here, those 2 sides are parallel. So yes, and what would your reason be? Both sets of opposite sides are parallel. That's your reason. Okay, number 8. Now look at number 8. Do you see how this angle here has 1 slash and this angle has 1 slash? That means they're congruent. See how this angle here has 2 slashes, this angle here has 2 slashes? That means they're congruent. So yes, this is a parallelogram. And what would the reason be? Right here, look at number 1. Both sets, whenever a quadrilateral has both sets of opposite angles congruent, then it's a parallelogram. Instead of writing all these out over and over, I'm just going to put the number. So number 1. Both sets of opposite angles are congruent. Now, number 9. No, there is nowhere down here, nowhere are you going to find a reason to call this a parallel. Yeah, there is, Mr. Hart, right here. 70 plus 110 is 180. You're right. But read this carefully. Number 4. When an angle is supplementary to both of its consecutive angles. So yes, I know this angle is supplementary to this angle, but it has to be supplementary to this angle down here too. So you'd have to have 110 degrees written right here, and we don't. Oh, that's being picky. No, it's not. This right here, you have no idea what this angle is. It could be 108 degrees. You do not know what that angle is right there. Okay? And so because of that, you cannot say for sure this is a parallelogram. Both sets of, an angle must be supplementary to both of its consecutive angles. Let's take a look at 110. Yes, 110 is supplementary to 70, but I have to know also there's a 70 down here. And then if there was a 70 here, which there wasn't, but if there was, then this angle here would also have to be supplementary to that angle. So if you want to use the supplementary reason, you must have 3 angles, and the middle angle must be supplementary to the 2 outside angles. Okay, that's the only way that's going to work. Okay, number 10. Well, sure, that's a parallelogram, definitely, and it would be reason number 2. Look at reason number 2. When a quadrilateral has both sets of opposite sides congruent, then we know for sure it's a parallelogram. Look, we've got a 6 and a 6. Those two sides are congruent. We got a 10 and a 10. Those two sides are congruent. Okay? Number 11. Yes, definitely. Look at reason number 5. Reason number 5. The diagonals bisect each other. See this segment from here to here? It has a length of 6. See this segment from here to here? It has a length of 6. And then we see this segment here has a length of 8. Excuse me for yawning, I apologize. And this segment right here has a length of 8. So these two diagonals bisect each other. Put a slash here. This segment is congruent to this segment. Put 2 slashes here and 2 slashes here. This segment here is congruent to this segment here. So yes, it has to be a parallelogram. Whenever you have a quadrilateral in which the diagonals bisect each other, then it's definitely a parallelogram. Definitely, definitely. All right, let's move on to number 12. Actually, we don't have number 12, and I knew that. Let me pull that up real quick here off my screen. Okay, if you have your test there in front of you, you should see this problem right here, number 12. All right, here we go. In quadrilateral EFGH, let's write that down. Let's make it look any way we want to. We don't have to be picky. There you go. There's a quadrilateral. Okay? There it is. EFGH. It doesn't matter where you start with the letter E, as long as you go in clockwise and you go in order. E, then F, then G, then H. So here's my quadrilateral EFGH. Angle E is 12 degrees. There we go. Angle H is 12 degrees. There we go. Angle F is 168 degrees. There we go. Is this a parallelogram? No. There's no way. I mean, look, we just said if you want to prove that a quadrilateral is a parallelogram and you have 3 angles like this, then the middle angle must be supplementary to this angle. That means they must add up to 1 angle, and it must add up to 180, excuse me, and this angle here must be supplementary to this angle right here. Well, it's true. 12 plus 168 is 180. So far so good. But 12 plus 12 is not 180. So no, this is not a parallelogram. That would have been the only way to prove that this quadrilateral is a parallelogram, by saying that, or by seeing that this middle angle is supplementary to both of its consecutive angles, and it's not. 12 plus 12 is not 180. So no, this quadrilateral is not a parallelogram. Okay, numbers 13, 14, 15, 16, 17, and 18. List each quadrilateral for which the statement is true. Consecutive angles are supplementary. Well, let's put numbers. We'll call this 1. We'll call this 2. We'll call this 3. And we'll call this 4. Now, consecutive angles are supplementary. Well, we know that's true for a parallelogram. That's one of the characteristics of a parallelogram. Consecutive angles are supplementary. So we know that consecutive angles are supplementary. We know that's true for parallelograms. Hold it, a rectangle is a parallelogram, so we know it's true for a rectangle. Hold it, a rhombus is a parallelogram, so we know it's true for a rhombus. And hey, a square is a parallelogram too, so we know it's true for a square. So all 4 of these objects have consecutive angles that are supplementary. Now, what about consecutive sides that are perpendicular? Does a parallelogram always have consecutive sides that are perpendicular? That means the 2 sides meet at a right angle. Well, no, not at all. This is a parallelogram, and we can see we definitely don't have a right angle right there. So no, that's not true for a parallelogram. Now, a rectangle, that's definitely true. We have 4 right angles all the way around, do we not? Sure we do, definitely. So it's true for a rectangle, number 2. It's not true for a rhombus. A rhombus can be kind of squished and twisted like this. No, there's not right angles here every time. Maybe sometimes, but not always. But a square, yes, we have 4 right angles, and thus if we have 4 right angles, just like a rectangle, it means the consecutive sides are perpendicular. Every single intersection point of 2 sides does form a right angle. So this would be number 3. Now, number 15, consecutive sides are congruent. Let's think about this. Consecutive, not opposite. Not opposite. Consecutive sides. That means 2 sides side by side are parallel. Well, that's not always true for a parallelogram. Look how little this side is and look how long that side is. Nope, not true. A rectangle, not always. No, look at this little side here. Look at this long side here. No, it's not true. A rhombus? Yeah, because what's the definition of a rhombus? The definition of a rhombus is a parallelogram in which all 4 sides are congruent. A parallelogram in which all 4 sides are congruent. So are the consecutive sides congruent? This side here, is it congruent to this side here? Well, yeah, all 4 sides are congruent. So we know that 2 sides side by side have to be congruent. Same thing with the square. If all 4 sides are congruent, then we know that any 2 sides that are side by side have to be congruent. So yes, it would be numbers 3 and 4. All right, number 16, consecutive angles are congruent. Now, that's not true. A parallelogram, we know that's not always true. Consecutive angles in a parallelogram are what? Do you remember? Supplementary. Okay? And so we do not know for sure that in a parallelogram that these consecutive angles are congruent at all. But in a rectangle, look at the consecutive angles. This angle and this angle, they're congruent. Consecutive means side by side angles. Or this angle and this angle, they're both congruent. Or this angle and this angle, they're both congruent. Or this angle and this angle, they're both congruent. So it looks like to me that consecutive angles, or 2 angles that are side by side, are congruent in a rectangle. Now that wouldn't be true in a rhombus. I mean, look how little this angle is here, and look how wide this angle is up here. Okay? And so definitely that's not true for a rhombus. Consecutive angles or side by side angles are not necessarily congruent. But for a square, that's true. Definitely. Angles that are side by side are congruent. Well, this is 90 and this is 90, and this is 90 and this is 90. So any of these 2 angles are going to be congruent. Okay, so consecutive angles are congruent. Diagonals are congruent. Now remember, that's not true with a parallelogram. The diagonals bisect each other, but they're not congruent necessarily. Same thing with a rhombus. A rhombus does not necessarily have diagonals that are congruent. Now a rectangle does, and a square does. So objects 2 and 4. If you were to draw diagonals like this and like this, those 2 segments in a square would be congruent, or in a rectangle, excuse me, would be congruent. And same thing in a square. If you were to draw a diagonal here and a diagonal here, those 2 diagonals in a square would be congruent. Those 2 diagonals would be congruent. So numbers 2 and 4. Opposite sides are congruent. Opposite sides are congruent. Well, that should be all 4 of these, I would think. We know that one of the characteristics of a parallelogram is opposite sides are congruent. And so here we go. Opposite sides are congruent. This is a parallelogram. A rectangle is a parallelogram. A rhombus is a parallelogram. And a square is also a parallelogram. So we know that if we have a parallelogram, opposite sides are congruent. And since all of these are parallelograms, then all of the opposite sides are congruent. Okay, let's take a look at numbers 19 and 20. Numbers 19 and 20. Find the missing angle measures in the trapezoid. Now, okay, here we go. Notice that we have an isosceles trapezoid. Do you see that? We have an isosceles trapezoid. Okay? Now, because of that, the base angles, we went over this in class, we learned this when we studied trapezoids. In an isosceles trapezoid, the base angles are congruent. That means if this is 110, then angle A is also 110. And then we also learned in trapezoid, consecutive angles right here are going to be supplementary. They will be supplementary. So if I have 110 degrees right here, then I must have 70 right here. Why? Because 70 plus 110 is 180. And when you have a trapezoid, and you take one of the base angles like this and the base angle next to it, a consecutive angle like this, and add those two together, you will get 180. You will. And so we know angle D is 70. Now, because we have an isosceles trapezoid, and by the way, Mr. How do you know you have an isosceles trapezoid? Well, because this side up here is parallel with this side here, and these two sides here are not parallel, but they're congruent. And when these two legs are congruent, then we know that we have an isosceles trapezoid. So we have an isosceles trapezoid. That means these two base angles up here are congruent, but it also means these two base angles down here are congruent. So if angle D is 70, then angle C is 70 also. Now let's come over here and take a look at number 20. This is not an isosceles trapezoid. If it was, this side here would be congruent to this side over here, and we do not have that happening. So we know for sure this is not an isosceles trapezoid. But here's what you need to realize with trapezoids. Look, anytime you have your base angles down here and your base angles up here, these two angles right here in a trapezoid will always be supplementary. Always, always. And these two angles right here will always be supplementary. Always, always. So if that's true, then I know right away angle B has to be 110 degrees, because 70 plus 110 is 180. And then also, we know that this angle right here has to be 125 degrees. How do I know that? Because 125 plus 55 is 180. And whenever, let me say this again, whenever you have a trapezoid like we do here, the consecutive angles like this will always be supplementary. Not these two angles here, but I'm talking about going from one base angle down to another base angle. These two angles here will always be supplementary, and these two angles here will always be supplementary. Always, always. Okay? All right, so that's something you need to know about trapezoids. Now, let me go ahead and say this in case it's getting close to the end of the class period. Your homework for tonight is to finish this video if we don't get it finished in class. And number two, listen to me. One of you talked about taking a makeup test. You said you didn't do well. Well, you understand that you're definitely taking everyone's taking the test tomorrow. We'll see how y'all do on that, okay? And then we'll make a decision about future makeup or retakes, future retake tests. But everyone tomorrow is taking this test, okay? All right, let's continue on. Now, let's take a look at numbers 21 and 22. Find the value of x, okay? Find the value of x. Now, I'm a pretty good teacher, decent teacher, but I have forgotten what the formula is, so I'm trying to think what we do. We add these two together and divide by 2. So I guess we could say 2 times the midsection, or midsegment, equals base 1 plus base 2. I'm pretty sure that was the formula that I gave you guys, okay? And I'm glancing back just real quick to make sure that's right, but I'm pretty sure that's correct, okay? But while I'm looking that up, we are going to use that formula now to solve 21 and 22. right, here we go. Let's go down to the very end. Yep, there it is right here. Here's the formula I gave you right here. 2 times the mid-segment equals base 1 plus base 2. Okay, very good. Just want to make sure I had that right. So I'm using this formula right here. Let's go ahead and solve number 21. Notice the x is on the mid-segment. So 2 times your mid-segment, or in other words, 2 times x equals base 1. It doesn't matter which one of these two you call base 1 and which one you call base 2. I'm just going to put an 18 for base 1 and a 24 for base 2. Okay? Isn't that easy? So for the mid-segment, I put an x. For base 1, 18. For base 2, 24. Now let's solve for x. 2x equals 42. Divide by 2, x equals 21. So there we go. The length of your mid-segment is 21. Now let's come over here. Notice I give you the length of the mid-segment here, but I do not give you the length of one of the legs. All right? So with that in mind, let's do a little erasing. Here's our formula that we're going to use, and let's fill everything in. 2 times your mid-segment. Well, your mid-segment is 19. So 2 times 19 equals base 1, we'll call that 15, plus base 2, we'll call that x. If you got these two turned around, if you put your x first and your 15 second, it doesn't matter. You'll still get the right answer, okay? Now let's solve for x. 2 times 19 would be 38 equals 15 plus x. Now bring the 15 over and make it a negative 15. So if you bring the 15 over and make it a negative 15, we're left with 23 equals x. 23 equals x. So there, you just found the measurement of one of the bases. All right? Okay, that's about, I mean, guys, you got to know the formula. Know the formula and you'll be okay. All right, numbers 23, 24, and 25, and we're finally done going over this test. Determine whether the quadrilateral is a trapezoid or isosceles trapezoid or parallelogram or rectangle, rhombus, or square. Now, there could have been more than one answer to these, okay? So first of all, I know 23 is a trapezoid for sure. Okay, because I have one set of opposite sides parallel. And the definition of a trapezoid is a quadrilateral in which we have exactly one set of parallel sides. And we have one set of parallel sides. Now the next question is this an isosceles trapezoid? And I'm going to say yes, it is. Definitely. Well, Mr. Aaron, I'm glad you say that, but how do you know that? Well, here's how I know this. Notice this angle is congruent to this angle. So let's just call it 100 degrees. We're just going to make this up, 100 degrees, okay? Well, if this is 100 degrees, remember in a trapezoid, these two angles right here are always going to be supplementary. And so if this is 100, this has to be 80. And these two angles here are going to be supplementary. So if this is 100 here, this is 80. And look at that. I know it's isosceles because my base angles are congruent and my base angles are congruent. So anytime you have a quadrilateral that has exactly one set of parallel sides, you know it's a trapezoid. And if you have a trapezoid in which your two base angles are congruent and your two base angles are congruent, then you definitely have an isosceles trapezoid. Now, is it a parallelogram? No, because a parallelogram has both sets of opposite sides parallel, and this side is not parallel to this side. Is it a rectangle? Well, the definition of a rectangle is a parallelogram, so we can stop right there. A rectangle has to be a parallelogram, and it's not a parallelogram. Is it a rhombus? Well, a rhombus has to be a parallelogram. The definition of a rhombus is a parallelogram with four congruent sides. Is it a square? No, because the definition of a square is a parallelogram with four congruent sides and four right angles. And so if this is not a parallelogram, then it cannot be a rectangle or a rhombus or a square. Now let's come over here. Notice that I have an angle in the middle and then these two side-by-side angles. Well, 90 plus 90 is 180. 90 plus 90 is 180. So I definitely know that I have a parallelogram. Remember, one of the ways to prove that a quadrilateral is a parallelogram is when this middle angle here is supplementary to both of its consecutive angles, like this. So we know we have a parallelogram. So I'm going to go ahead and put parallelogram. But if I have a parallelogram, let's see what else. I know I can't have a trapezoid, that's for sure. It cannot be a trapezoid or an isosceles trapezoid, because an isosceles, any trapezoid at all, a trapezoid has only one set of parallel sides. And this object here has two sets of parallel sides, because it's a parallelogram. And if it's a parallelogram, then we know we have two sets of parallel sides. So this cannot be a trapezoid or an isosceles trapezoid. It's a parallelogram. Could it be a rectangle? Well, the definition of a rectangle is a parallelogram that has four right angles. So yes, we have a parallelogram. How do I know this is a right angle? Well, if I have a parallelogram, I know that opposite angles are congruent, and if this is 90, then this has to be 90 down here. So do I have a rectangle? Yes, because the definition of a rectangle is a parallelogram, and we know we have a parallelogram with four right angles, and we know we have four right angles. So yes, this is a rectangle. Now, is it a rhombus? No, it's not a rhombus. A rhombus has to have all four sides congruent. Is it a square? Well, no, we have to know that all four sides are congruent, and we don't. So no, we do not know for sure that it's a rhombus or a square. Okay, coming over here, notice I have these two sides are congruent, and these two sides are congruent. So one of the ways to prove that you have a parallelogram, do you remember one of the ways to prove it? Is to say both sets of opposite sides are congruent. When both sets of opposite sides are congruent, then you have a parallelogram. Well, these two sides here are congruent, so there's one set of congruent sides. These two sides are congruent, so there's another set of opposite sides congruent. So that's one of the ways you can state that you have a parallelogram. So we definitely have a parallelogram for sure. Okay? Let me grab a drink of water here real quick. Now, if I have a parallelogram, that means this side here is parallel to this side here, and this side here is parallel to this side here. So coming back up here, I know that I cannot have a trapezoid or an isosceles trapezoid, because the definition of a trapezoid is a quadrilateral that has only one set of parallel sides. Only one set of parallel sides. And here we have two sets of parallel sides. So we know for sure that this is not a trapezoid or an isosceles trapezoid. Now, it's a parallelogram. Is it a rectangle? Well, the definition of a rectangle is a parallelogram with four right angles. Do we have a parallelogram? Yes. Do we have four right angles? Yes. So we know that we have a rectangle. All right, let's take a look at a rhombus. The definition of a rhombus is a parallelogram with four congruent sides. Do I have a parallelogram? Yes. Does it have four congruent sides? Yes. So it is definitely a rhombus. Is it a square? Well, the definition of a square is a parallelogram that has four congruent sides and four right angles. Do we have a parallelogram? Yes. Do we have four congruent sides? Yes. Do we have four right angles? Yes. So it's definitely a square. Okay? Now this is how you're going to have to take the test, okay? This is what you need to take home and study. Study this tonight. Call or email if you have any questions. Please don't hesitate to do that. And of course I'm going to mix the test up. That's what a teacher does. And I'm going to change a lot of stuff on it. But this will be a very good foundation for you. And remember, well, let me back up. This will be a very good foundation for you when it comes to studying for your test, which you will take on Friday. So we have a new rule. The new rule from now on is whenever I give you part 2 of your math tests, in which there's math problems on the test, not fill in the blanks, but math problems, there will always be a video to go with that test, and you are to watch the video first. So this Friday, if Mr. Harmon or whoever your teacher is passes out your tests and they don't say to you, hey, here's a video you need to watch first before you start your test, you need to raise your hand and say, Mr. Harmon, Mr. Earhart said there should be a video for us to watch. And there will be. And you put the test on your desk, and you look at the test while you watch the video, and I go over the test with you, okay? Call or email if you have any questions. Hope you guys have a great day today. Please study for your test tonight, and we will take your test tomorrow on Friday.